5. In a certain population of men, 5% of men have coronary artery disease. A diagnostic test is used to indicate whether or not a man has the disease, but the test is not always correct. For men who have the disease, the test is correct 24% of the time, while for men who do not have the disease, the test is correct 98% of the time.
So this is statistics.
No, it's not. It's probability.
Yeah.
If a man is, there's a question on this test about standard deviation. That's statistics. If a man is randomly chosen from the population and the test indicates that he has the disease, then the probability that the test is correct is which of the following, or closest to which of the following. So, what we're going to do here...
So statistics is low-level math. Why
No, it's not.
GRE math test has a statistics?
It's not low level.
Oh, okay.
And there's lower level math on here.
Okay.
Okay, so anyway, what to do in these situations, these conditional probability problems, when you don't remember the Bayesian probability formula, is to just assume there were 1,000 men in our population. 5% of these men is, of course, equal to 50%, which means that of our entire population, 950 people do not have the disease, while only 50% do have the disease. So now, we're going to categorize the test results by whether they are wrong or whether they are right. So, the test goes wrong for healthy people only 2% of the time. 2% of 950 is, of course, just 19. Yeah. So the test goes right for everybody else, which is the other 950 minus 19, 931 people. Meanwhile, you have these 50 people. The test goes wrong for, the test goes right for 24% of them. Which means only 12 of the infected men get the correct answer. Meanwhile, exactly 38 of the men who take the test get 38 of the infected men who take the test get a false negative. So here's what we have. This is the number of false positives, the test marking people as infected when they really aren't. This is the number of true negatives, the test marking people as negative when they are negative. This is the number of false negatives when the test marks someone as negative when they're truly positive. And this is the number of true positives when somebody is positive and the test marks them as positive. So, if a man is randomly chosen from the population and the test indicates that he has the disease, which means it's one of these two groups who receive the positive result, then the probability that the test is correct, which is only for this group of people, is closest to which of the following. So, of course, the test is correct for 12 of the people who took it and got a positive result, and overall, 12 plus 19 people took it and got a positive result, which means that the test will be correct for 12 divided by 31 of the people who took it and got a positive result. So, we're going to want to simplify that. So we're going to estimate it to be about 12 divided by 30. And of course, that's just equal to 2 divided by 5, which is equal to 40%. So, the guess is that it's going to be E, 39%. And of course, if you actually calculate what 12 divided by 31 is, it is 38.7%, which means that the answer is, calculators aren't allowed, by the way, which is why I did the estimation trick. Which means that the answer is E, 39%. So that's it. Thank you everybody for watching.